Now in this section I'm going to quickly summarize some of the advantages we get with the multicast before we go ahead and try to understand how exactly the multicast works. So in the previous sections we have seen if you're using unicast, it's going to send a separate copy of information for each and every receiver. So the more number of receivers you have, the more amount of packets it has to send, and it's going to utilize more amount of bandwidth. But whereas in case of broadcast, you can expect the receivers who don't want to receive the multicast traffic, they can still receive, and it is also not a recommended solution. So instead we are going to send a multicast where it is going to send only one copy of the packet to all the receivers, and they will identify based on some special address. Now the major advantage we get with the multicast is it's going to reduce the server processing utilization, because the server is going to send only one copy of the information, and better bandwidth utilization and less host or the router processing is required when it comes to multicast if you compare with unicast or broadcast. So it's going to save the bandwidth and reduces the network consumption as well. So the next thing let's try to understand how it's going to save. Now the server is going to generate only a single stream of information, whereas in case of unicast is going to send multiple streams. Now the sender or the source of the multicast traffic do not have to know the destination address. Now whereas if you are sending a unicast traffic, in case of unicast, the sender must know what is the destination address. If the destination address is unknown, in that case it will be broadcasted. That's something mandatory condition. But whereas in case of multicast, the sender is sending to a group address, and we call that as class D address we use for that. And without knowing the actual receivers, the sender is going to send to multiple receivers. We'll see much more in detail how exactly it's going to work. Now the server is going to send only one copy of the information, whereas the routers are going to do the multiplication of those particular packets depending upon the number of receivers. And it is not going to send to the receivers who don't want to receive. So the uninterested host will not receive the packets. Now the major advantage with the multicast is, like here, let's say I got more number of clients here, here. Now the more number of receivers I have, as the number of receiver increases or the clients increases, it's going to increase the bandwidth utilization also in case of unicast. But whereas in case of multicast, even though you have some hundreds of receivers, so the bandwidth utilization remains the same. So it's not at all going to impact the performance of the network, even if you have hundreds of receivers or more than that. So that's one of the major benefit we get. It has some enhanced efficiency which controls the network traffic and reduces the server and the CPU loads. There are some very basic drawbacks of this multicast, like as the multicast is a UDP based, you do expect the packets getting dropped as it is UDP based, and you don't expect the reliability of the data. That's one of the drawback we can say. And it's going to use the best effort delivery. There is no acknowledgements again, and there is no congestion avoidance mechanism, because in the TCP you have some TCP windowing kind of thing which will help in reducing the congestion. But here there's no congestion avoidance mechanisms can be done. You can expect the duplicate of the packets at the time of network congestions and out of sequence delivery. So these are very, very small drawbacks we can say with the multicast, but it's a common way to send the multimedia traffic to multiple receivers.